Good afternoon, everybody. Welcome back. Moving on to the second problem statement, radiological image-based condition detection and report correlation, which focused on radiological images and their corresponding diagnostic reports. As both the images and reports are available, the objective was to develop solutions that can analyze and compare the findings from the images with the observations recorded in the reports, identify any inconsistencies between the two, and also detect contradictions or discrepancies within the reports themselves. May I now invite the winner under problem statement 2, Mr. Harish Kumar from team BiltIQ AI, to take the stage, please.
He can.
Yeah, if you let's make it. Good afternoon, everybody. First, I would like to thank NHA for organizing this such a hackathon, which allow small startup like us to participate in this competition. So, about us, we are BiltIQ AI from Jharkhand, Jamshedpur, and we have a small team who work on the regulated environment, like for healthcare. So we work on the regulated environment, whether it's a healthcare, BSFI, or EdTech. So where data is very important, where we can secure our data on premises. So we work on a solution which run offline using AI. We already built Sios AI for US-based healthcare application, where with Dr. David Montorano, we build a patent-based solution for behavior health solution. And for India AI Summit, we developed this POC where you can compare private insurance with the PMJY, and we can see that what are the benefit in PMJY healthcare benefit against the private insurance. And in AI Summit, NHA director Vikram Parage was there in our booth, and he told us why you guys don't doing for India, why you are doing for international Canada. After that, it encourages. After that, we decided we should participate in every hackathon will happen. We missed the exchange claim one, but this one we wanted to crack it. Okay, so this is about us, and we have our own hardware solution. We don't use cloud AI. We use own hardware where we do all the regulated work. About the Sios AI, let me give you a brief about how that EHR works. It's a multi-agentic system which work on a very regulated environment in US healthcare. One of guy was talking about the fire and HIPAA and all those stuff. So we are highly work on that environment where we have to take care about all the compliances, PHI and all those stuff. Again, the RAG insurance, we just talk about that. It's again multi-agentic POC, but we can develop this as a large-scale product. We apply for API through API Setu, haven't approved yet, but we want to build this for Indian user to use and understand how to different benefit through our insurance or PMJY. Now coming to our problem. So problem is that NHA have to process lots of claim every day, and they have to approve the claim, legitimate claim also. So the problem is that when we provide a report or radiological image, it must correlate with the report. So that's the problem. An image cannot be changed, the image date and all those stuff, and report can be inflated. So that's where we have to create an AI pipeline which compares both the image and then the report, and based on that, give the human adjudicator to take an informed decision. And again, it's had to be take very fast processing. Okay, so where the AI model is used, where we use the code. So you can see that image reading, we use the vision tier of Gamma. Gamma by default is a multimodal, but we use as a to report correlation, we use the Nemotron because it has a thinking capability and the reasoning model. So that's why we use that. But before going to the LLM, we process through the classical Python pipeline so that we not consume too much token. Building an AI system, one thing we have to aware that token uses. So that's where, whether we are using a foundational model, whether we are using open source model, token usage is very important where we can save our lots of token. So we use for image OpenCV, data extraction, we use the regex, calendar math, so that date consistency can be done. Then STG alignment, we convert the STG guidelines into the YML file. Why YML? Convert into YML, and then the parsing of the narrative so that template can be created. Now, if we use if you see that we have a two process, one is the image lane, one is the report lane. So image lane, first is check the quality. Again, it's not LLM or VLLM, it's an OpenCV which classify the image, how good his image is. Whenever we talk about the radiological image, it's always a good in shape. If it's very old, if we go to the STG guideline, if it's old, OpenCV will tell that this is a very old. Then again, vision model amplifies that. CR takes extraction from the report, and then medical model that, although we are, for medical, again, we use the Nemotron Nemo only, because for his that model capability. Otherwise, I would prefer use MedGamma or other model which has a medical vocabulary much better than the Nemotron. But here we use the Nemotron, so which parse the reports and then the check for the consistency. Again, it's a correlation. Does image support the remote? And we have a multiple section that if it's a consistent, yes, it's a straight go. Confidence level is more than 90%. 90, we can say that yes, this claim is legitimate. If partial, is informed for the human reviewer to check that. Again, if unsupported, again it notify the human user to check this manually. Again, STG and timeline, right package, right mobility. So based on our STG guideline, it should check because all the radiological image has the date on it. So based on the date and the report, it could correlate with each other. So based on that, and again, whatever the output, we use the JSON output, which our model can read, and then the reviewer PDF. We use Python, any Python version more than over 3.12, it can work. MyPDF, OpenCV, NumPy, we use Gamma and Nemotron Nemo for this. It took us to process 40 claim 82 minutes, but it can be improved. In sandbox environment, we were given 16 GB of RAM and 4 CPU, but and we can only run one worker. If we run a multiple Python worker, then we can improve that that process. Again, if how our algorithm worked. So if image shows the hyperinflation in lungs is present and report says hyperinflated lungs, it just check the keywords. Based on that, it can say that it's consistent, and for quick approval consideration, set if it's written in that particular gallbladder unremarkable, but in present. Again, it's a partial supported. We cannot say that it's a fake or fraud. Human reviewer can review it and then process. But again, this will be the slow process. So that's how our algorithm work, where if a report is consistent, it can go for a faster process. If report is not consistent, then it will go for the human reviewer part. statement and our so for what we believe that layer can do the document forging. So first we have to check that if a document is forged or not. If it check in the first class, first step, we can reject immediately and it cannot go to the layer 2 or layer 3. Layer 2 is our problem statement 1, where page classification, field instruction, all the NLP, and then the timeline validation can be done. And the third layer will be the our PS2, where evidence with the, so this is, if we are going to scale this complete solution in this open source model, but I think if we use a better model, then we can process more claim more efficiently. Again, diagnosis, tone leak, honest, so what we, so not seen is not means not accessible. If image, LLM or my code is not able to process that document, I think it should not be rejected right away. It should go to the human reviewer to check that. And it was an air gap solution in sandbox where no data is going outside the NHA environment. And this, right now we run on the AWS environment. I think NHA can run on the, instead of using AWS, can we run on NIC hosted GPUs? And even this solution can run on the single hospital or kiosk using a DGX Spark, like a small AI machines, which can run offline. It can run also because we already tested all those stuff, and we understand that we can run that offline also. So where are the different failures? So we talk about that gamma model capability, where image, it cannot be understand. So what we did, we added an OpenCV gate which identify and classify the image first. Then the reporting. Most of the hospital, maybe some hospital purposely write the wrong report, or report is something we cannot understand. That's where per package chronicle phrase and STG rule need to match, and based on that we can decide whether it can approve automatically or we can send for the human reviewer. Again, image quality, false positive. Yes, image can be degraded, or OpenCV can be give the false positive. So, and that case, not seen or normal is coming. We again, if confident is less than 90 score, we can tell the human reviewer to check that again. Data extraction, yes, sometimes handwritten, multilingual data cannot be extracted. Even in our solution, we're not allowed to use Tesseract multilingual, where we can do with the Indian language, all those stuff. But if null or failed, I think we can data unreadable flag, again, it can be assessed manually. One of the question previous question was asked, how we are going to onboard new package. So how we are going to onboard new package? We convert all the STG into YML configure file. We don't need to change our code, anything. We just add a YML extension file. It will work with the algorithm. So we don't need to train or process our data through RAG or any AI model. We just need to put the proper YML file, the config file with the new guidelines or new package. How we can improve that? So if we have to develop a complete fraud detection system and the claim processing system, we need a GNN, graph neural network, which can learn itself. How it's going to learn? Based on the previous data processing and all those data, proper level data. Model can run itself, and then it's continuously online. It will adopt how it's going to be. And same method we use in SIOS AI also, where based on the patient previous document, it suggests the provider that what kind of treatment can be given to that particular patient. So same method we can use here also. Again, for Indian context fine tuning, yes, we have to work with the multiple Indian language where we can, but if NHA can standardize these process through the FHIR messages, because that is very important part in healthcare. If we standardize the messaging process instead of handwritten document or a PDF. So that should be an policymaker should look forward it, and I think it's compulsory for the hospital to use FHIR standard of the in their EHR. So that these kind of things, I think if we upgrade, then I think it will be a very a good system, and I think Indian healthcare need those kind of processing, because if we see the complete processes, how the healthcare work, like in opening remarks, sir was saying that yes, in US you have to wait. Even a European country, you have to wait for a treatment for weeks and months, even over small ache and stomach. But in India, providers are very fast. But if we give them a right tool, I think we can solve one of the problem. And what I believe in India, that we are still not using EHR or digital document for healthcare. This is where I think if we start using it, I think healthcare is the first industry which can be fully capable for AI processing. So I think this is where we can really work on it. So how the all system will work? So this is a data table that we thought that should work. So like if integrity is there, the document is clean, then it comes to the PS1 rule. If it's passed, consistent, auto approve. That's how we can. If again is a first step is a tempered document, we don't need to directly label that is a document fraud. Again, if clean, PS2 can be skipped, and honest non-compliance, because query hospital about the messaging is whether it's a wrong package or whether the report is not there. Again, third step, if we have a clean first and second step, third is not supported, then high priority fraud signal, real document and rules is followed, but image and report is not matching. It means there is some fraud. So those kind of things we can implement, and then our GNN can learn. And also the pattern, it can identify which hospital follows this kind of pattern, and it can detect that. So it always alert that if request coming from this particular agency or hospital, we can manually verify all the document, so that those documents not pass through the automatic process. Thank you. Any question?
How you are using actually GNN for real-time working, basically, particularly, offline it is static analysis is okay, but while processing the claim, how you are handling it?
How GNN works? GNN works is a pipeline where we have an approved data set. So we label the data that these are the approved and these are the rejected data. So GNN is an algorithm to automatically understand this kind of system is approved. There is a detection if 3 layers, 2 pass, 1 is fail. So GNN is using an algorithm which using the graph neural edges of the graph, it can learn, okay, it's a correct document or not, and it keeps feeding us. So it using my own data. So data set that we are processing, where we are saying that it's claimed approved, not approved, how much time is manually approved, based on those GNN automatically learning that process. So that's where so that pipeline we need to create. So first we have to see the NHA system where they are approving all those and disapproving the claims, and that data need to feed it to our GNN algorithm, and GNN will start working. So we have to write the algorithm by looking that data and then start approving or disapproving the claims. So I think I saw just a second.
Any one case today?
Yeah. So this is again from our test data. So we given the one test data. It's a claim number PMJ SGR, where image shows the hyperinflation of lungs is present. So what happened? Vision model checked that although we got the JPEG or PDF, we prefer DICOM, I think, direct radiology image format. It will be much easier for LLM to learn. So, and report says hyperinflated lungs, like doctor like to say in 2 words, or report is say that. So that's one. Is both are consistent. Based on that, it's a reviewer action, quick approval for. So that's one example. Another example of fraud signal is again it's the same. We use the data set provided by NHA. Image shows the gallbladder is unremarkable. Yes, it's in ultrasound is not showing the stone or anything, but reporting multiple gallstone and required an immediate operation or kind of thing. That's kind of claim come to the NHA mostly. Both are the partially supported, is not accurate. So that required a escalation closure so that human reviewer can review that both image, and so you don't need to go through all the files. You just have to check which flag for the review. So that saves lots of time for a reviewer.
We are interested to know about your approach for these false documents, like tampered documents. Yeah,
it's a problem statement 3, where yeah, it's a different group. Actually, we participated in all 3, but we won this. So this presentation is regarding PS2. But yes, as a whole system, fraud detection done via first stage, where we didn't selected in this hackathon. But yeah, so we use again OpenCV and Python library to identify. It's no LLM involved in that. So it's a pure classical programming there to detect the.
So it will be coming in the next set. That will be presented.
No.
Okay.
We are. So problem statement 3 is different.
Excuse me, I'm not sure the question what I'm asking is concerned to about this or this software support us whether the amount being claimed for one particular package is sufficient enough or will be added up, or how we have to work on this.
So this is a problem statement second, in which he demonstrated how we can actually correlate the radiological image or a scan with respect to the report. So that was the only problem statement which they have worked on. To answer your question, so that is different. Yes. So
how is your image? You are concluding that hyperinflation in lungs is present from the image data.
So it's a vision model. It reads the image. So LLM reads the image and it tells that. So although we use Gamma, which is not very good in vision, it's an older model, but newer model is doing much better than in vision. But yes, vision model can read nowadays, even if
okay, so the model already has that training,
yeah,
and it gives that
yes,
it is
yes.
present.
So they trained on the multiple medical data and all those stuff.
okay, can I have one? I'll give you. So for GNN, how you are handling heterogeneous data complexities? That is my question.
That's we haven't, because
data
I need to understand first, then I will create the pipeline based on the data, because the data that said we got is a very limited. So we need to understand that what kind of data we are getting. But algorithm can be created based on understanding the data.
how are you handling a case where a report or a lab report has been made which was not necessary? Essentially, one is where fake lab report or something that, like that has been mentioned, but one case might be where there is a waste abuse, not exactly hard fraud. Some unnecessary investigations had been made. How would you counter that?
I think that's what NHA is doing that.
So for the problem statement too, the problem statement was if you are given let's say X-ray. First of all, whether the X-ray is of the same patient for which the claim is submitted. There is no forgery or there is no name change. There is nothing has changed. Then you have a report which is attached with any diagnostic. Doctor signs it. So another thing was to check a consistency in that report, and the third part of the second problem statement was to check the consistency between the diagnostic report and the report attached with the diagnostic report. The consistency, what X-ray is saying and what the report attached with the X-ray is saying. So they have that limited option. But you are asking the deepfake, that's the third problem statement. And and another thing that you asked is, let's say somebody has, it was not required. Let's say diagnostic was not required, but that hospital has done a diagnostic just to inflate the bill. So that is catered in the first problem statement, where it was like all the documents required as per STG is there. If there is any extra document, that auto adjudication engine will mark that this is an extra document. So then the reviewer or adjudication can happen accordingly.
The first winner, Harish Kumar from team BiltIQ